Hello and welcome to Miss V's math class. In today's video, we will be talking about function notation.
Math, numbers,
sine wave.
Function notation, we may see equations that would normally be written with y equals. Let's just say, we'll do an easy one. Let's say y equals 2x. And in place of the y, you will sometimes see written f of x equals 2x. Well, as we know, y is the dependent variable. It depends on x. So therefore, y is a function of x. All that this means is that there is a function that depends on x. If we put in 2 for x, we know that 4 would come out for y. We can change the values for x. We can put in anything we want for x, and some number y is going to come out, also known as f of x. Let's say x is equal to 1. So on this side of the equation, in place of the x, I'm going to write a 1. F of 1 is how we say this. So I'm putting 1 in for x on the left side, and I'm also going to replace x on the right side. So instead of 2 times x, I'm taking 2 times 1. Well, 2 times 1 is 2. So that tells me when x is 1, y is 2. Okay, I could do the same thing with a negative number. For example, let's say negative 3. If I want to find the function at an x value of negative 3, all I need to do is replace x with negative 3. So I'm going to take 2 times negative 3, which gives me negative 6. So the y value, where x is negative 3, is negative 6. Okay, I think we get the idea. Mainly, this has to do with notation. So if you are asked in a question to find f of, let's do a fraction this time, let's say 4/3. Okay, they want you to evaluate this function at an x value of 4/3. That's what this notation means. So again, all we need to do, 2 times 4/3, which is 8/3. That would be your solution at that x value. Now, in the previous example, I used f to represent the function. All that f is a name. That's what we're calling the function. It doesn't have to be f. We could use g. So for this next example, we're going to use function g of x, and we'll say that that is equal to x squared. We're going to do a quadratic function. Do another negative. Let's say g of negative 1. Okay, now this is a great example where we need to be very careful that we are replacing x with negative 1 and not just 1. So make sure that your negative goes into parentheses so that we know that x is actually a negative. Now anything squared means we're taking that number times itself. So this is negative 1 times negative 1. Negative times a negative is a positive.
Why?
Well, thinking about your order of operations, what's going to happen here if you put this into a calculator? This means something different than this expression, okay? This means 1 squared and then made negative. Now 1 squared is 1 times 1, which is 1. Then we make that negative. That would give us negative 1. These are not the same. So please be careful with your parentheses on these.
For practice worksheets as well as fun activities, check out my website at Teachers Pay Teachers. The link is in the bio.
So maybe instead of just being asked to find g of negative 1, you're asked to find 2g of negative 1. All right, we know that putting a coefficient in front of a variable simply multiplies that variable. This is no different. G of negative 1 represents an output. We're going to simply take that output and multiply it by 2. So above, we already found g of negative 1. We found that it was 1. So I can replace this entire g of negative 1 with the number 1. So 2 times 1 is 2. Okay, same exact thing. If I said 5/3 times g of negative 1, I would simply replace g of negative 1 with the 1. So you give me 5/3 times 1, which is 5/3. Calling this one h. Rather than using x this time, I'm using t. Again, it does not matter what variables we're using, but I do know, thanks to this notation, which is the independent and which is the dependent. So So this tells me h depends on t, 20. Alright, so I'm replacing t with 20 over here. I'm going to do the same thing on this side. 20 divided by 10 plus 5. 20 divided by 10, that gives me 2, plus 5 is 7. Okay, easy enough. What if we were told that h of t equals 7, and we want to solve for t? Alright, so many people will be tempted to just replace t with 7, but that's not what this is asking. It's not saying t is equal to 7, it's saying h of t is equal to 7. So, I know my function h of t is equal to t over 10 plus 5, okay? So I'm going to substitute on this side in place of h of t, I'm going to rewrite this function. T over 10 plus 5 equals 7. Now it makes sense. Now I can go through this and use algebra to solve for t. Okay, I could subtract 5 from both sides. That gives me t divided by 10 equal to 2. To remove the 10 in the denominator, I can simply multiply both sides by 10, and this leaves me with t equals to 20. Okay, which we already knew because we had done this one. Let's say we have two different functions, f of x and g of x. And I am asked to find f of g of x. Okay, well this is interesting. Now in the function f, we have replaced x with g of x. Now we know what g of x, we see the function right here. So I'm going to substitute, in the place of that blue g of x, I'm going to substitute x plus 1 because the two quantities are equal. So I'm going to say f of x plus 1. Now, one more step. I'm going to go back to my function f, and in place of x, I'm going to substitute x plus 1. So the function f is 2x minus 30. Okay, normally, if it was f of 2, I would replace this with a 2. If it was x of 4, I would replace this with a 4. Since it's x plus 1, I'm going to go ahead and put in x plus 1. Alright? Now, if I want to go ahead and fully simplify this, I can use distributive property. 2 times x is 2x. 2 times 1 is 2. And then I'm not forgetting to subtract 30 on the end. Positive 2 cancels 2 of my negatives and leaves me with 28 negatives. So this would be f of g of x. In contrast to the last problem, what if instead of f of g of x, we were asked for g of f of x? We're going to use the same method, but backwards. We are now replacing f of x with the other side of the function, 2x minus 30, and then we're going to replace the x in the g of x with 2x minus 30, leaving us with 2x minus 30 plus 1. The negative 30 and the 1 can combine. That leaves you with 2x minus 29. So as you can see, this is not the same thing. Once we switch these letters around, you are going to have a different result. So as you've seen, there's a lot of different things we can do with function notation. Sort of some different kinds of problems that you might see out there. Get to it and start practicing. And I wish you all the joy that comes from having a mathemagical day. See you next time.